My name is Estelle Smith, and I'm a PhD candidate in human-computer interaction at the University of Minnesota. Thank you so much for watching this pre-recorded ICML 2020 talk. The talk is titled Keeping Community in the Machine Learning Loop. And this talk is based off of an accepted CHI2020 paper. I wanted to call out my co-authors, Bowen, Anjali, Aaron, Lauren, and Hayi for their instrumental contributions to this work. And I also wanted to just let you know that Hayi will be presenting this work live in my stead during the actual conference dates. So this workshop is about participatory machine learning. And one prime example of participatory machine learning systems are human-in-the-loop systems. And typically, when we think about these types of systems, there are three main components. The first is some type of a repetitive task. And I'm mostly going to talk about patrolling Wikipedia for vandalism because that was the context of this research study. The second component is some type of an algorithm that is going to semi-automate the task. And the third is that we have a human who is looped in at the end to complete the task, because the assumption is that we generally trust human judgment more than we trust machine judgment on any individual instance. But there's a little bit of a problem here. Specifically, every individual instance is decided by one human, yet there are many, many community stakeholders who are possibly affected by the outcomes of that decision. And we know that the way that we design these types of systems can influence human behavior. So the question that we're motivated by this work is, how can we keep the entire community in the loop as we're thinking about how to build these systems to make sure that the outcomes are actually representative of what the community as a whole wants? We completed this study in the context of Wikipedia looking at the OR system, which is the Objective Revision Evaluation Service. ORS is a collection of machine learning algorithms that is accessible as a web service and API. It generates real-time edits or real-time predictions about edit quality, as well as draft and article quality or topics. ORS has been live on Wikipedia since 2015. And ORS looks something like this. ORS is embedded into a huge variety of different tools and interfaces across the Wikipedia ecosystem. But the general idea is that we have a lot of edits coming in from the internet at large, and those are represented in this diagram by little gray dots. ORS takes a look at each one of those edits as it's coming in and makes a decision. Is this likely to be a good edit so we can let it by, or is it damaging, in which case we should remove it immediately? But then there's these kind of edge cases where we want to have some type of a human to look at them to make the decision because the machine really isn't sure. And so we loop in a human at the end to make a decision about whether or not this edit or this article is going to stay up on Wikipedia. We used a method called value-sensitive algorithm design in order to understand what are the community values that should be guiding these types of systems like ORS, for example. So value-sensitive design or algorithm design, otherwise known as VSAD, has three different parts. The first is to understand stakeholder values early in the design process. The second is to use those values in order to guide the design of the algorithms. And the third is to evaluate algorithms based not only on their accuracy, but also on how well they satisfy values. And this work is primarily looking at the first issue of understanding stakeholder values. In order to understand the Wikipedia community's values, we conducted 16 interviews across the 5 stakeholder groups that you can see listed below. And after we analyzed the interview transcripts, we found that there were 5 convergent community values that should guide the design of machine learning-based systems like ORS. So machine learning systems should reduce the effort of community maintenance, maintain human judgment as the final authority in any individual instance, support differing people's differing workflows, encourage positive engagement with diverse editor groups, and establish the trustworthiness of both people and algorithms within the system. And in practice, we suggest that these values should be integrated from the beginning to the end of the entire machine learning development pipeline. Specifically, these values should be considered as we're developing the algorithms themselves, the user interfaces that interact with these algorithms, as well as the work processes that call on both the algorithms and the user interfaces beneath them. So thanks for listening to this talk. I hope that you've enjoyed it, and we would love to talk about your thoughts on these. Please get in touch with me at the email address below, or you can find me on Twitter at @me, myself, and HCI. Thank you.